Good day to you all. You are welcome to Linear Stereo College class. And the topic that we have on the board is Taylor's theorem, or we can say Taylor series. So now, the question here is, obtain a second degree polynomial to the function f of x equals to square root of 1 plus x by means of Taylor's expansion about the point x not equals to 0. So now, under Taylor series, if you are asked to expand the function about the point x not equals to 0 or x equals to 0, that means you are using Maclaurin series. Maclaurin series is used to expand the function at the point where x is equal to 0, while Taylor series is used to expand the function at the point where x is equal to a, that is, the value of x is not equal to 0. And again, we obtain the formula for Maclaurin series from the Taylor series. So now let's go to the solution. So the function given is f of x equals to square root of 1 plus x. So which can also be written as 1 plus x raised power 1 over 2, that is half. And the formula we are going to use to obtain the second degree, don't forget that the question says obtain a polynomial of second degree. So second degree polynomial to the function. And the formula to obtain that will be p of x equals to, that's f of 0 plus x l prime of 0 plus s square l prime of 0 over 2 factorial. So that is the formula we're going to use to expand this particular function to obtain the second degree. The question says, obtain a second degree polynomial to the function. This is the second degree. So we are stopping at the power of 2. S raised power of 2. That is the second degree. And why this one is the first degree. So s raised power 1, L prime of 0. And all this prime means what? Derivative. We differentiate once with respect to x. And this prime means we differentiate twice with respect to x. Now, after differentiating first and the second time, wherever we see x, we will substitute the value to be 0. So now, don't forget that f of x is equals to 1 plus x raised power 1 over 2. Now, to differentiate this, we can actually use some chain rule to differentiate this, but let's learn the shorter form of obtaining the derivative. So to obtain f prime of x for this particular function that we have here, the power is 1 over 2. We'll bring down the power. 1 over 2 will come down. Then we're going to differentiate what we have inside the bracket. Differentiating 1 with respect to x will give us 0. Now differentiating x with respect to x will give us 1. So we'll multiply this by 1, open bracket, 1 plus x, raised by 1 over 2 minus 1. So what I actually did over here is, to differentiate this particular function with respect to x the first time, we'll bring down the power, which is 1 over 2 will come down. Differentiate whatever you have inside the bracket. Then we'll use it to multiply that 1 over 2 that I actually brought down. Then the power will subtract 1 from the power. So from here, we're going to have f prime of x is equals to 1 over 2 in bracket 1 plus x raised power minus 1 over 2. So now by the time you simplify the power that you have here, that 1 over 2 minus 1, that will give us negative half. That is, we'll find the SCM. 1 over 2 minus 1 over 1. The SCM is 2. So 2 goes here, that's 1. Times this one, we have 1. 1 goes here, that's 2. Times this one, that will give us minus 2. So minus 1 over 2. So that's what we have here. So now, we can also rewrite this as 1 over 2 times, so this can also be written as 1 over 2 times 1 over 1 plus x raised by 1 over 2. So we can also rewrite this f prime of x as, that's 1 over 2, then square root of 1 plus x. So it's still the same thing. So what we have here and this, they are all the same thing. So they are still the same thing. So now the second time, we need to differentiate the second time with respect to x. Because here we have f prime, then we have f prime prime. So we have to obtain the second degree polynomial for the particular function given. So now we need to differentiate the function the second time. So now don't forget that we've differentiated it the first time, f of x, and that will actually give us f prime of x to be this, or we can say this particular one that we have here. So let's say this is our f prime of x. So if f prime of x is equals to 1 over 2, 1 plus x raised by minus half. Now to differentiate it the second time, so that will be, here we have 1 over 2 here, times this raised power of minus half that we have here, we'll bring it down to multiply this. That will be minus 1 over 2. Then times, we differentiate 1, that will give us 0. We differentiate x, that will give us 1. Then we open a bracket, 1 plus x raised power, that will be minus 1 over 2 minus 1. So this will give us L prime prime of x is equals to, this times that's minus 1 over 4 in bracket 1 plus x raised power minus 3 over 2. So by the time you simplify the power that we have here, this particular one that we have, that will give us minus 3 over 2. We'll find the SCM. That will give us minus 3 over 2. And don't forget, that is not all. The next thing I will do is, at the point x naught equals to 0. So that means we'll go to this particular place. At the point x naught equals to 0, we'll start from here. We want to obtain f of 0, L prime of 0, and also L prime prime of 0. So now, at the point where x naught is equal to 0, then we'll start from here. Where x is equal to 0, we'll start from here. Wherever we see x, we'll put 0. Then we'll now go to the next one that we have here, L prime of x. Anywhere we see x, we'll put 0. So that's the next thing I will do now. So let's start with this particular one. So, at the point x equals to 0. So f of 0 will give us, so that's 1 plus 0 raised power half. That's 1 raised power half. 1 raised power anything is equal to 1. So now the second one is L prime of 0. So we'll go to L prime of x. Anywhere we see x, in that case, we substitute 0. That will be, we have 1 over 2 there. 1 over 2 is here. In bracket, 1 plus 0 raised power minus half. That will give us 1 over 2 is here. In bracket, we have 1 raised power minus half. That will give us, that's 1 over 2. Because 1 raised power anything is 1. So now the next one, which is the last one, that's L prime prime of 0. And to obtain L prime prime of 0, we'll go to L prime prime of x. Anywhere we see x in L prime prime of x, we'll put 0. And this is L prime prime of x. So wherever we see x here, we'll substitute 0. That will be L prime prime of 0 equals to minus 1 over 4 in bracket 1 plus 0 raised power minus 3 over 2, which will give us minus 1 over 4. So don't forget that f of 0 is equals to 1. Then L prime of 0 is equals to 1 over 2. And L prime prime of 0, that's negative 1 over 4. Now, finally, let's go to the final answer. So from the formula we have to use is P of x is equals to f of 0 plus, here we have x, L prime of 0. This one is over 1 factorial, but that 1 factorial is same as 1. Here we have s squared, L prime prime of 0 over 2 factorial. And this 2 factorial is 2 times 1, which is 2. So now, that means this P of x represents the f of x that we are solving. So which is square root of 1 plus x in bracket is equals to, expanding this, f of 0 is 1, x is here, L prime of 0 is 1 over 2, plus x squared is here, L prime prime of 0, that's negative 1 over 4, over 2 factorial will give us 2. That is 2 factorial is, that's 2 times 1, which is 2. So now let's simplify this. That will give us 1 plus x over 2. Now we have minus, that's s squared over 4, then over 2. Now to get the final answer, so we need to simplify this particular one. And to simplify this, same thing as s squared over 4. So I have s squared over 4 divided by 2 over 1. That's s squared over 4 times 1 over 2. So from what we have there, that will give us s squared over 8. So we have s squared over 8 from what we have there. That's s squared over 8. So that means the final answer, therefore, square root of 1 plus x is equals to 1 plus x over 2 minus s squared over 8. Kindly like this video, share it and follow for more.